All right, I'm back, still on page 262. Pretty much promise this will be the last video on 262. We're gonna finish this and then look at the Desmos thing. You don't have to watch the Desmos thing. I think it's enlightening. I think it's a good idea. I'm gonna spend my time doing it, but it's up to you. All right, so after entering your piecewise function on your calculator, I did that. You don't have to do that. It's terrible. I'm gonna show you in a minute. Create a new function that gives the percent of taxable income that is paid in taxes. So to just like think about it. So T of X, as I've defined it up here, so T of X is taxes, dollars paid on X dollars of income, taxable income, but let's simplify it and just say income, right? So that's what T of X is. So T of X spits out how much you pay in tax. So I'm gonna say R of X for like your rate, like your effective tax rate, not like the bracket that you're in, but like what percent of your money are you paying in taxes? So R of X should just be T of X divided by X, and then times 100 if you want to get like the percentage out of it. Sometimes I leave off the times 100 and I just like in my head use, multiply by 100. Really, I just move the decimal place, but it's up to you. So I think that'll do it. All right. I think that'll do it. Let's go to the calculator where you'll see I already entered it for you. So you can do it if you want, like totally fine, right? So here you go. You can see I actually typed it in wrong the first time. And like when I checked the graph to see if it made any sense, in the last branch here, it was like 0.396 times however much you made, and then subtract 413,200, which left it like the government just owes you hundreds of thousands of dollars. Felt like a little authentic, to be honest, but definitely not how it should have worked. So here, I fixed it, and then I just like played around with it, see what would happen, right? So I mean, it's definitely working. So now, what's your effective tax rate, right? So if you make $100,000, right, that's a great goal. That's like a lot of people feel like once I make that much, that'll be it. So if I do that, I'm going to define a new function, which is T of X divided by X, and then times 100. So if you make $100,000 and you just look at the tax table at the top of your notes, you would think that you're going to pay 28% in tax, but you actually are effectively paying 21%. Why are you paying 21%? It's because you only paid 10% on the first like 9,000. Then from like 9,000 to 37,000, you only paid 15%. Then from 37,000 to 90,000, you only paid 25%. And then, so like, you just pay less on the first dollars that you make. And it really like, over time, kind of like, it adds up, right? So like your effective tax rate, if you make, I don't know, $1 million, let's see, probably pretty high. I mean, the limit as we go to infinity of this tax rate should be 39.6. Is this a million? 3 zeros, 3 zeros. Yeah, 35. So at a million, you're like creeping up. You're getting closer to it. How about a billion? 1, 2, 3, 1, 2, 3, 1, 2, 3. This is going to be close. 30. That's very close, but it's still less, right? But like an enormous percentage of the money that you made, $1 billion, an enormous percentage is at that 39.6% rate. But it's only the limit. You can actually never get to 39.6, even if you go to infinity, because you like started out below $413,000, so you paid less on that. So the limit will be 39.6, but you actually cannot mathematically get there. All right, so I keep saying that we're going to look at a Desmos thing, so let's do that. So I'm going to switch over here. This is available to you if you want to play with it. Go to student.desmos.com, type in 6KD-DNE. In like 5 weeks, that probably won't work, but right now I think it will work. So what I'm going to do, because I'm the owner of this, I'm going to do this in an incognito window, and then I'm going to have to share that with you, I think. Actually, I don't know. Let me see. Let me try to share this window. Can you share an incognito window? Debatable. I don't actually know. Maybe? It seems, yeah, all right, I got a green window around this. I hope I'm not like just gonna be talking at nothing the entire time, but I'm going to continue without signing in. Enter a name. It's me. And I'm going to go. All right, so this, like, we don't have to do all the calculations because we did them. So the first thing, the image on the left shows text, right, whatever. Let's deal with the first two rows. All right, so here's our graph. And dragging K, so it's like you're paying 10% on everything up to 9225, and then you're paying 15% minus whatever K is from 9225 to 37450. So let me move this. And you can see that as I increase the amount to subtract, this whole branch just starts moving down. We know that the value should be whatever we know it should be, 461.25, but that's effectively what we did. We made the limit from the left equal the limit from the right equal the value of the function. We made it continuous. All right, so blah, not doing that. Okay, so now what I'm gonna do, this is not exactly what we did. I'm just gonna move each branch by itself, and you can kind of see what's happening here. So I'm gonna change A. And look at all of every one of the branches is moving. That's because everyone who's in those like buckets of dollars made is getting to take this off their taxes. So everyone gets to take this amount off. So about 7,000, I guess. So this is the third one. Let me take a look at my notes on my iPad and see. Yeah, so this is the value of A, right? We calculated A, we got 6928.75. Okay, so the next thing is not the same as B in the notes, but the number down here will be. So this we actually got 6928, let me fix this, 6928.75, but this is the last one I'll be able to fix because, ew, had the row. Okay, now what I'm gonna do is just like make the next part continuous. And to do that, I need to subtract like 9,700, I guess. 9,600. Look at this number, 16,528.75. 16,528.75. So we got 16,393.75, which would be the correct answer. This looks continuous. If I zoom way in, you'll see that it's not. That's like a large numbers type of thing. But this number is the sum of A and the amount that I just shifted this down. So this is what we get. Let's make this little branch continuous. So I'm gonna move this down. And you can see that everything is moving down that isn't already continuous. Get there. This will total up to 24. So we got 24,328.75. When we did it, we got 24,623.75. In your table, that's C, right? So on this, it's A plus B plus C. That's because I did a bad job naming things. And now we got to fix this gap. So I'm going to move it until it's like roughly there. And we get 4,328.75. All right, and then when we did it mathematically, we got 43630.95. We created this continuous function, which was our goal. So it's pretty neat that it works. So blah, blah, blah. All right, so here's where we can type in our numbers, right? So our numbers were 6928.75. And then, don't do that. Okay, so this is continuous now. And then our next number, the shift for the 33% tax bracket was 16,393.75. And then our shift for the 35% bracket was 2424. You can watch it like move a little bit as I type 623. And it like basically looks right now, 0.75. So this is how we can tell that we were right. And then our shift here for the 39.6% bracket was 43630.95. Continuous function. And that's what we wanted. We want our taxes to be continuous so that there aren't those, I mean, there's a lot of problems in the world, but one of them that we don't have is that our tax bracket isn't continuous. It actually is. And that's good. So this other approach, if you want, this is basically the approach I did on the calculator. I found the tax on the current row, tax on the next row, found the difference. And you could like see them fill in if you wanted to. And then you can fill in this table if you would like. I would not like to. So I'm actually going to cut the video here and I'll be back with more for the next video. So I will see you then.